Good day, everyone. Welcome to this session at SQL Bits. Today, we're going to talk about data tiering and data virtualization in SQL. My name is Ajay Jagannathan. I'm a principal group program manager in the Azure SQL product team. Our team is responsible for building the various SQL products as well as capabilities in the product. Thank you for joining this session. We'll cover some of the capabilities we have introduced in different flavors of SQL and our vision and plan with how data tiering works, right? So at a high level, we'll be covering several topics today. I'll talk about what are this is a new paradigm, especially for relational database folks. So I'll talk a little bit about the principles of what we consider data virtualization is and what are some of the benefits. I'll share more details about our own journey in various SQL products, how we have evolved from the early days to the current and latest versions and going forward. There have been some architectural changes during this journey, so I will share some of the changes that came and how it benefits you for your use cases. And then how do you get started? How do you enable these scenarios in SQL and get going and using this? We'll talk about that. Use cases are important. I mean, that's what data virtualization is here to address. So we'll talk about few common use cases we are seeing customers leverage this for. And we'll talk about some best practices to get the best out of the system, best performance, and leave you with some tools, some learning resources so that when you get started, you have this as for your benefit. Feel free to ask questions during the session. Happy to stay after the session too if you have additional questions. So what is data virtualization or principles? So data virtualization is basically a concept, and the technology we use in SQL is called Polybase. How many of you have heard of Polybase or have used Polybase? So yeah, so that's good. Quite a few are familiar with this, so we'll cover that. Some of the key principles for people who are new to this, right? Accessing data outside of a relational database is not trivial exercise. It's very complicated. It can be in different file formats, different storage systems. So the goal, one of the key principles is how do you make, abstract all the complexities of data access, whether it's authentication, encryption, permissions model, everything from the application users. Make it simple for application users to go get the data wherever it resides. That's one of our core principles. And just give a simple credential to access, and the engine should take care of all the other data handling capabilities. The second thing is zero replication, right? Many people before the days of data virtualization have to use complex data movement technologies, ETL processes, etc., to get the data in or move it around, and it causes a lot of other problems like latency and storage, duplication of storage, because if you're copying the data, it's an extra copy of this. So one of the goals for this is how do you access the data where it resides, right? The couple of benefits, obviously, from a storage side, you're not creating extra storage needs. The second benefit is you're getting more real-time access to data as it sits where it's at its source, and near real-time access. So your analytics and other systems can leverage the latest copies of data instead of waiting for next snapshot or refresh, right? So that's another key principle. The third one is, I briefly touched, like real-time data access, which is basically just connect to the underlying data and then combine it with your relational database and do all kinds of complex patterns and analysis. So you have a mixture of both types of data to leverage according to your application needs. So what are some of the key benefits of data virtualization? I've highlighted the top 5, which we commonly see from customers. As I highlighted, the first one is no data movement, which means you get cost savings from not having additional storage. Right? Storage can get expensive. So this provides a cheaper alternative to many other technologies that are out there today. The second thing is our goal and vision with SQL is be able to make it a data hub, right? Many people are very familiar with SQL Server as a product, T-SQL language as their programming language to engage with the database and various data assets. How do you make it easy to do the same thing with data outside SQL Server? So that's one of our goals of this Poly-based project is make SQL as your central data hub to access data wherever it resides, right? And we'll look at a demo going through different examples. Power of T-SQL, yeah. I mean, one of the things SQL already provides is everything from programming language, query processing engine, query optimizer, which can be smart about filtering, push downs, everything. So how do you leverage all of that automatically for data outside the database? The fourth one, security is important. SQL Server has a rich set of security features. As I mentioned in the intro, we don't want the application users have to worry about data security. So let SQL Server engine handle that. So we want to make it easy for business users to separate the access of the data and have to worry about setting permissions and granular controls, which can be handled by the database administrator itself. And finally, we want to make it available everywhere. So today, it's available in all editions of on-premises SQL Server, from all the way from Express Edition to Enterprise Edition. It's also available in our cloud offerings. Azure SQL Database, it's in preview, and Azure SQL Managed Instance, it's already available generally. So whichever version of SQL or flavor of SQL you're on, you should be able to use this. So that's one of our key goals. Any questions? I'll pause here for a second. Okay, so let's move on to the journey itself, right? So the journey of Polybase started back in 2016 when we introduced the first version. It was based on Hadoop, providing access to Azure Blob Store for external access to your data. But the functionality and features were limited, where you could not export the data, you could only read from the data and things like that. Then came 2017. We introduced Open Rosette, which gave more flexibility in terms of accessing different types of databases and or file formats. We introduced CSV support in addition to Azure Blob Storage. Open Rosette helps you with data exploration as well as data pruning, which we'll look at as an example. And then we introduced a security model where database scope credential, where you could set up a credential-based access to your external data from within SQL, and the credential can be protected by a master key so it doesn't get hijacked. And then you could access this data anywhere it runs, right? And SQL 2017 is also our first version of SQL Server supported on a Linux platform. So this also expanded your footprint to, if you're running SQL 2017 on Linux and you want to use Polybase, that was an option. In SQL 2019, we added the ODBC data sources. So if your data is not sitting in an external store, but other database systems, some of which are listed here, the popular ones, obviously SQL Server is itself another SQL Server can be an external source, but other popular databases like Oracle or Cosmos DB or Teradata, etc., if customers wanted to access that data from within SQL Server, they could do it through Polybase and get it more efficient than using, let's say, Link Server, right? And then 2022, which is our latest and greatest on-premises release, we enriched this completely. We rewrote a completely new architecture. We will talk about that. We call it the V3 architecture. We integrated with object storage, which is now a popular format and provided by various storage vendors as well as cloud providers. So we wanted to make sure we support the storage formats as they evolve. This also allowed us to expand us to support other storage formats like Delta and Parquet, which is very common in the data virtualization world for external data for big data systems. So SQL Server now natively supports this. And then one of the most popular requested features, which was there for our Synapse or data warehouse queue, was CTAS. Create an external table as select, where you could actually export or move the data out of your relational databases, especially the historical data, so that not only you have better space management for your hot data, but you can archive and yet still be an active data for historical data sets, right? So that's the evolution, and obviously in the cloud now it's available, as I said, all flavors of Azure SQL. So if you want to use it there, you get the same thing. And that's the journey. Now, let's look at the architecture and how it's evolved, right? Obviously, we start from top down, right? SQL Server sitting on the top, that's your data hub, and that's where you want to access your data, which is stored wherever. And then now you have three different ways to access your data externally. One is open row set, which I said, which is for exploration. The second one is external tables, where you basically project your external data as a table in relational table in SQL, and you will be able to access it just like you would a regular table, and we'll look at examples. And the third one is for export scenarios, which is through CTAS. So we have two architectures below that. One on the left is poly-based services-based architecture, which we call the V2 architecture, and with the green outside box. And as you can see, this old architecture is a poly-based service-based architecture, which installs services on your SQL Server as part of your setup. And then it lets you connect to various databases like Oracle, Teradata, SAP, to name a few. And then the latest architecture is what we call V3, the gray one on the right. This is basically a REST API-based interaction, right? So it's much more scalable, simpler to use, and it provides two different types of data access. One is on the left is Azure storage. So if your data is residing in Azure Data Lake storage, ADLS Gen 2, for example, or Azure Blob Store, you can do that using the new syntax. Or if you have any S3 compliant object storage, as I mentioned, we introduced object storage support. So a lot of the storage vendors today support both hardware-based as well as software-based object storage. Just to clarify here, S3 was actually, object storage as a concept has existed for a couple of decades, but only in the recent times it's become popular with Amazon defining a standard as an S3 open protocol. So any S3 supported storage, now you can access, even if the data is sitting in, let's say, AWS or GCP or any of these storage systems, and if they support an S3 REST API interface, you can just access it from SQL Server. You don't have to have explicit different ways of moving data there, right? And the data itself can sit in different formats, and now with Parquet, Delta, CSV, and text becoming the popular storage formats for data, you have full access to this. You also have some S3-based solutions available in Azure Marketplace, if that's something that you're looking to use. So you can also look over there. MinIO, for example, is a software-based. You can just install their software stack and then install their drivers, and then you will be able to set up S3 type file folder structure just like you would with a hardware-based storage. Dell, for example, has something called OneFS, which is a hybrid solution because some people also have data in traditional file systems in addition to S3. So you have an opportunity to integrate both of that through those kind of systems too. So that's the internal architecture of how SQL can interact with these different storage systems. And we will look at demos with some of these scenarios. I'll pause again. Any questions? Yeah. Great question. The question is if with V2 and V3, is it going to be in parallel or one of them will go away? So right now, both of them coexist, and SQL Server, and you don't have to do anything special to access one of them. So depending on where your data is, SQL Server will automatically use either the V2 code base. If you're using any of those sources, it'll go to using the V2 code base. If you're using the new stuff, it'll use the V3. But eventually, we'll migrate everything to the native architecture. Yeah. Anything online yet? Okay, thanks. A little more details on the architecture itself, on comparison of V2 and V3, right? As we saw in the diagram, V2 is a service-based architecture, and then V3 is a REST API-based architecture. Other key difference, V2 is basically for ODBC sources, where you can connect to other databases, and V3 can connect to any data files, right? Um, and V2 was primarily for Azure storage account support like Azure Blob Store, whereas V3 also had support for S3 compliant storage. Another key difference, V2 is based on the Polybase service. So when you install SQL Server in your setup, I'll show a diagram shortly, is you have to install Polybase. For V3, you have to install it temporarily, but it's not used. It's because the way the software was built that is required, but the service itself is not used. And finally, the entire Polybase code for V3 is inside the engine itself, so which is why I said the service is not used, whereas for V2, it requires installing V2 services. So if you are, depending on what services you are, or what data sources you're going to access, we will automatically pick either the V2 or V3, just to reiterate that. So how do you get started, right? So here's the setup dialog that you will see when you install SQL Server 22 setup, for example. I know it might be hard to read there. So the one which is highlighted, it should say install Polybase query service for external data. Make sure that is selected, because that's the one that installs the right components. It installs two services on your system. One of them is called Polybase Engine, and the other one is called Polybase Data Movement, right? The Polybase Engine, as you say on the top right, that's your core engine, which think of it like the query processor for Polybase, meaning that's the one that processes your incoming queries for Polybase, compiles it, creates an execution plan, and then picks the best plan to go fetch the data and etc., right? And then the Polybase data movement works with the Polybase query engine to do the actual data movement between your source and destination, right? And if you have named instances of SQL Server, obviously we will create a named instance of these services too, so that you can easily identify and recognize those. The other setup requirement is you have to go into, once you install SQL Server, when you go to SP configure, you will see some new properties, right? Make sure the Polybase enabled is turned on, enable the first setting. The second one is allow Polybase export. By default, we allow Polybase export is not turned on because some customers are very wary about data exfiltration for unauthorized use. So you have to go explicitly allow export. So if you have to run commands like CTAS, if this is not on, that'll fail. So make sure that's turned on. If you're using the old V2, obviously the Hadoop connectivity setting should be turned on. And finally, if you're doing like ad hoc queries, right, with the old architecture, then the last setting needs to be turned on, ad hoc distributed queries. So those are the main setup requirements to get started with Polybase itself. And then let's see how to use some of the new capabilities, right? One of the things I mentioned is once you install the services, it's important that you enable those configuration. And in V3, since everything is running natively, it's important to know how to get this going correctly, right? Polybase itself is database scoped, like because all the queries you're running to fetch data thing it's in the context of the database where you start your work, where you run your CTAS, for example, or open row set. So the first thing you need to do is create a database scope credential, right? If you're accessing a public data set, which I'll show in the demo, you don't need to create a data set because public data set is anybody can connect. Like a lot of data sets are published, like government data sets, or like, for example, COVID-19 data set or a population data sets. A lot of these are publicly available, so you don't need to create a credential. The credential is only required if you have to protect data residing in your environment, right? These are private data sets. And as part of creating the credential, we also have to create a master key. The master key is what is going to protect your credential from getting hijacked, right? So once you create the two, these are the two prerequisites. You create a data source, right? So the data source is basically a URL to where your data resides, right? If it's an Azure Blob storage or an S3 compliant storage, there's a specific syntax to the URL, and you say, here's my external data source located, right? Like it's like, for example, it's like a link server definition. If you have to create a link server to another server, so So you just point it to the file location or file path and format and etc. Right? And then you specify an external file format. Right? This helps if, for example, if you are accessing a CSV or TXT, there's no schema or metadata persisted inside those type of files for SQL Server to know what the data type is. For example, if you have an Excel file there and it has 20 different columns with strings and numbers and different types of data, SQL Server doesn't know what type of data type they are. So it's the external file formats will basically help you map your column as it reads from those to a certain data type so that it projects itself as a relational database. If you're using Parquet, Parquet is already built in with a schema in it. So you have one advantage that it easily maps. I'll show you an example on how to look at the metadata inside a Parquet file so you know what type of schema it is. And then the first thing people normally do in data virtualization is when data exploration. For example, if you're exploring a public data set and you don't know the structure of the distribution of data, like are they organized with certain folders, file structures, what is the metadata, what is the schema, what subset of data I need. So just for data exploration and data pruning, you can use something like select open row set, maybe limited to like top 100 or something so that if it's a large data set, you're not running the query forever. You just want a quick preview of what it looks like so you can set up your CTAS and other following access points correctly, right? So use open row set first, and then you create an external table, right? So this is where you get the power of SQL Server combined with Polybase to work together and use all the query performance or query optimizer benefits to get very efficient access to data. You can export your data to your Parquet Delta format, set it up in an organized structure. You can do all kinds of things like joins, aggregations, filters, and it'll behave just like what a query optimizer would do. And these are all some of the best practices we will share later, which will help eliminate performance issues or other things, right? And the right configuration is very important. And it'll be a game changer, right? You will see that even with large data systems with millions of rows, you can access it very efficiently than you would if the same data was in a relational database. Right. Good question. For database scope credential, is it possible to do Entra authentication? Yeah. So the short answer right now, it's using SAS token. This is something we are looking into adding because Entra is becoming like the prevalent method for access. So we will look at exposing something like this in the future. Yeah. Okay. So now let's look at some of the common use cases, right? These are the top 3 use cases. The first one is data hub, right? Here, SQL Server is your central hub, and then you can connect to all these different data sources, whether it's in database systems, like SQL or other relational databases, whether it's in storage systems, which are file systems, or whether it's in big data systems using Parquet Delta formats, right? So the biggest benefit here is you don't need to do any ETL. You can basically do ETL on the fly, right? Using appropriate T-SQL joins, aggregations, filtering, you get the data, rich data access the right way you want to do your queries. The second thing is we are also seeing a lot of customers doing small scale analytics right inside the database. SQL Server has always supported analytics, right? A lot of customers before the evolution of Power BI or Fabric, etc. Most customers ran their small data marts within SQL. That continues to happen. It's very lightweight, so you can use some kind of small scale analytics, continue to use this because you have an option to now look at all the data at the same time. And then the third one is offload and export, right? Think of this as data archival, right? As the data explosion happens in relational database, and we all know that it gives a headache for every DBA that as the database becomes larger, database maintenance is a big problem, like index maintenance, backups, everything takes longer, and storage is a problem, time for maintenance is a problem, and things. So a lot of customers are looking for ways to keep their OLTP system lean, like databases only keep active data or hot data, as you call, what is whatever is defined by the industry. Like financial industry may require, let's say, I need 1 year of data hot, rest of them can be archived. But you also want the ability to archive it for longer term. In the old days, archiving means backing up to tape or some offline storage where you don't have real access, right? Somebody wanted to audit or get access to old data, they have to wait for a few days so till the old data is restored, and then you can look at the old records. But that problem is solved here, because with exporting this data into a big data storage, now not only you're offloading and keeping your database small and lean, you also have real-time access, right? With open rosette query or CTAS, et cetera, you can actually look at that older data and you can meet your security and compliance requirements that way. So that's the big benefit that a lot of customers are leveraging with this scenario. Any of you have heard of StretchDB or used it? Yeah, so this solves some of the challenges and problems we had for which StretchDB was designed. So now, yeah, so let's look at, I spoke a lot of concepts and best practices. Let's look at various examples on how to do this, and we'll walk you through some of the core scenarios, right? So the first thing is, as you can see, we have to create a master key to protect your database scope credential. So I'm just using a random password to do that. And then the second thing is, I'm going to show you a public data set. Actually, if you want to learn this, if you go to Azure Open Data Sets, you can see by different industries, all the different data sets are published here. And then you can use any of this. For this demo, I'm going to use the Seattle safety data. So this is basically if any citizen calls 911, which is a US emergency line, that call is recorded, and they have actually published the schema of their data is actually stored in Parquet. They've published what the schema is, how do you access it. They've also given the actual open rosette query if you want to explore the data set, which is what I'm using here. So since it's a Parquet data set, I can directly run. Note that I'm not passing credential here because it's a public data set. And you can see that I have all the historical records. I can directly pass the URL since it's an Azure Blob Store. I can directly pass the URL to that. But passing the URL every time is inconvenient. So I create an external data source called Seattle Safety. So that way I just need to call that data source. It's like a pointer to the actual source and get the same results, right? It's more efficient than typing the URL every time and making syntax errors. You can see that this data set has about 1.8 million rows. And it's fast. I'm accessing a public data set and it returns results very fast. And now I want to look at how the file folder structure is laid out. Because if it's laid out correctly, I can be more efficient, as I said, in thing. And you can see that this is structured in eight different file paths or file locations. So this is useful to know because it'll help me determine how it's going. Now I'm going and create a view on top of this, so that again it simplifies having to repeat writing complex queries and joins when I'm doing the actual data exploration. So I created a view on top of the open rosette so that I can just use the view going forward. I can do select star from view instead of typing the whole thing, which is what I do here. And then you see, you get the results. And all these are going against the public set, remember, so it's not locally stored. And you can see that we did a remote scan to retrieve your results for your top rows. Now, I can do more complex grouping and aggregation, so I can see all this historical data, how is it grouped by year or month basis. And you can see that it breaks down the number of rows or number of incidents in this case for every year and every month. Roughly 5,000 to 7,000 calls are happening in a month is what you can glean from this, right? And how do I look at the metadata for this? So we have a stored procedure called SP describe first result set. As I mentioned, since Parquet already stores the schema in there, by running that, I can see all the data types for various fields inside those files. What is the collation? What is the size, etc.? Because this is useful in some of the performance best practices we will talk about in a minute, right? So when I query the view, you can see that this This roughly runs in 14 seconds and returns 1.8 million rows. Uh, Next, we will do some aggregations against this same data set. Before that, I want to compare the plans of, um, yeah, so we have, about a million or 100,000 rows for every year. So what I'm going to do here is I want to export this data into my own personal storage. Since I'm bringing a public data set to a private location, I have to create a database scope credential, right? We already created the master key. The next step is to create the database scope credential and pass the secret. So that will help me, and that's the blob store location of my private storage. So I'm not using S3 here, I'm using Azure Blob Store. So now I'm going to create an external data source because I need to export it to that location. And I'm also telling the external data source that I want to export it as Parquet format, not CSV or text. So this helps me maintain the same file format. Then I create an external table which will reflect that Parquet data on the external store as a SQL table with metadata here, right? And I want to maintain the same folder structure. Note that I'm passing a year as a filter. So this is where the query engine helps, right? It'll filter and use push down to make sure it doesn't scan the entire 1 million rows. So you can see that now we have, once you run this, it creates an external table that reflects the metadata for the Parquet file, which is sitting in my private data store. Now, if I go to my private data store using Azure Storage Explorer, you can see that it's created the year 2003 folder, and it has exported all the files. Anyone know why it has created 8 files? Sorry, what's the way the partition is implemented? It actually depends on number of CPUs you have in your system that SQL can use, right? If you have 8 CPUs, it creates 8 files, so it parallelizes the work, right? But if I want to loop through every, so here's one best practice. So instead of having to go through one at a time, you can specify the cursor. So let me go back a little bit. Yeah, so here what I'm doing is, first I showed you only 1 year. Now let's say I want to create a structure for each folder. I could loop through each folder in the cursor and tell them to create a file path. So using the file path, it creates, instead of putting all the 20 years in one folder, it breaks it down into folder by folder. So that's actually a best practice. It's kind of just like you would do table partitioning within SQL, you're doing partitioning on a file system, right? So you can see it creates folder, and this is a recommended best practice so that when you actually query, it can leverage the filtering and push down and bring you only the data you need. And you can see that we create the schema for each folder and keep it in SQL as a metadata so that when we do the joins and querying, it'll help, right? And then I can actually create a view on top of that data source for all the folders. So this is another benefit than doing a union all of individual folders. I'll show you the query plan shortly. So right here, I'm creating a single view for on top of all the folders. And this is another example which we recommend not to do. The other way to do it is union of each individual selects, right? Now, once you create these 2 views, let's compare what the performance looks like, right? So let's go and query both of these views, filter on just 4 of the years, right? One of them uses the best practice of the file path. The other one is just a union for just 4 of those 20 years. And let me turn on the execution plan here. And you can see it takes a long time to run, so I've already captured it. The top one is the Parquet folder structure. You can see that it just did a single thing versus you can see the number of round trips it had to do. So you will actually see network traffic going back and forth for each seek select, and then it brings it back into SQL and then does the union. So that's very expensive, right? So both performance, network traffic, and latency. So we recommend using the best practice. We have actually, in my resources section, we have a link to some of these push down and best practice recommendations. Um, so, and some more ways to explore the file path, file name APIs. So this will give you how to explore with Open Rosette. If you are querying an external Rosette, how it is structured, what is the folder name, etc. So this will help you write the queries correctly, right? And in this example, I can actually directly use file path to query. That also uses filter, so I don't have to use external table. Open Rosette accepts file path as filters. And then if I query only on those 4 years, I will get the same performance as the view. Now we are comparing those 3. You will again see the union one is the slowest, and the top 2 are reasonably comparable. The Open Rosette ran much faster, almost same as the file path with external table, and the union one was the slowest, right? So either of the exploration with file path or the external data source with file path is the recommended way to do it. Yeah, this is just showing that it processes the same row counts. And the main difference is the execution time. Okay, so next, this demo looks at one more thing. Actually, that was the end of the demo. So let's continue with the slide.
Can I ask a couple
Yeah.
more questions? One is on the computation part. So if I mean, you showed like we can get directly data from the Parquet and then we can do the computation. So when we run that query, where does the compute happen? Do we bring all the data in to the SQL server and then the computations happen within the SQL engine, or will the Polybase takes care of that?
Great question. So it depends how you write your query, right? It's just like link servers, right? If you use the best practices, indexes, and things like that, you can actually leverage the query optimizer. You can create statistics on this.
Okay.
If you set up the folder structure and partitioning correctly, if you don't use things like union, if you use the right data, some of the performance stuff I've called out here, then we can push down the execution to the compute to the external source, right? So especially with the other relational databases too, it's very important.
Okay. So the next one is like.
So the important point is to bring the right amount of data in.
Okay.
Right? And if you're joining with a table in a relational database, once you bring the data in, the joins happen inside SQL engine. Yeah.
Fine. Okay. The second one is like memory management. So for example, we have few people who just run everything, get everything from the lake. So we have some of them are like close to 200 gig, and some of them are like close to a terabyte. How in that scenario, how will that be handled? How do we know, like whether it's a SQL Server engine or the Polybase?
Yeah, the query plan is your friend there. It'll tell you how much memory was granted to which
Okay.
part of the thing. So if you're seeing a lot of memory consumed by Polybase, then you may want to tune the query to make sure you're fetching the right data, right? So
yeah, last one. Sorry.
Yeah.
The database scoped credentials. Can we have the keys per container? Let's say, because we have these permissions are set up at the container level. So if I want to give a SAS key per container, so that I don't have a cross-link here and there, instead of giving a storage account key, can I give a SAS key at the container level so that I can have restricted permissions on each container?
I'm not sure. We have to check on that. It may not be allowed,
Okay.
but I can follow up with you on that. So if you can ping me later.
Cool. Thanks.
Yeah. So continuing with the common challenges, right? First thing is access, right? A lot of times customers try to use Polybase, they run into challenges trying to access it. So make sure your setup is correct, right? Check your SP configure settings. Make sure all the right options are enabled like we highlighted in the other slide. The other one is the URL syntax is important, right? For if you're using data in Azure Blob Storage, use ABS : whatever the full path is. The third, or if you're using S3, now we support S3 : the URL. Check if the URL is correct. And the third one is obviously credential access to that, as well as the expiration of your token. Sometimes you set up the token with a limited expiration. If you suddenly lose permissions, then you want to make sure you want to set it up correctly, right? The second part is performance, right? This is where people spend a lot of time, right? Especially if you're using SQL Server and you're accessing data if the data is local, then obviously if it's in a fast disk subsystem, then you may not see that problem. But if you're using external storage or data locations in Azure or other clouds, the proximity matters, right? Just like if you're connecting from SQL Server to any other Azure service. So make sure the storage region for external data is in the same region, or you have very fast access to that region. The file sizes, ADLS itself recommends file sizes to be 100 GB or 10 GB or less. So make sure you follow that practice. From a data type standpoint, a recommendation is to avoid nvarchar max or varchar max type data. Parquet and Delta actually recommend using bin2 collation for your data type for best partition. And then use partitioning. Like I said, file folder path structure or table partitioning matters depending on where your data is stored, so that you can filter and access the right data and not spend resources having to move a lot of data around when you're doing querying or joining, right? So these are some of the common practices we recommend customers to follow. And then our documentation goes through a lot more detail by data source, how to set it up for each of these. A lot of resources available for you to troubleshoot, right? Obviously, if you are exploring data and you want to understand what type of metadata is, use the spdescribe result set function. You have catalog views to look at your definition of your everything from an external table, external source, formats, and then from an execution time, if you want to look at whether it's waiting or using resources, you can use any of the DM exec functions. So that helps you with any performance troubleshooting, so that you can easily find the issue and troubleshoot that problem. So these are some of the kit we recommend for you to have. And then a lot more learning resources available. This is actually a Learn module available for free. If you want to get started, just go there. It's about a 1-hour learning module where you can learn more about data virtualization and how to use this. There's probably some demos there. And the tool links at the bottom give you access to all the resources we talked about today: permissions, concepts, demos, public data sets, everything. So that's something that's available for you for free. So these are the main overview of the data virtualization, and it's one of our goals, like I said at the beginning, is to bring SQL Server customers the ability to use this concept to access data anywhere, right? We realize that now data is not just sitting in a database, but multiple different systems. This way you're able to reduce the effort owing to how complex ETLs have the benefits of real-time access, archiving older historical data and keep access. So it helps you better manage your database systems and yet get full business insights. So that's the end of the session. Feel free to leave feedback here, and thank you for coming. It's left, so I'm happy to take more questions if needed. Yep.
Hi, thanks a lot for this amazing session, first of all. A very generic question. According to you, what do you think data virtualization compares to architectures like Medallion? I mean, what according to you is the thing that virtualization lacks in and architectures like Medallion are better at?
Yeah, so like I said, this one is mainly for us to bring data virtualization to relational database, right? If you're bringing the use cases we discussed, like data hub or like data export, if you're doing full-scale analytics and large-scale analytics, then obviously you will have to look at best practices like what Fabric provides or data warehouse systems provide and things like that. This is like, think of this for best case, this is for more hybrid scenarios. where you want to work with relational database along with data in other systems, and also leverage technologies to move data around to between relational and non-relational systems.
Uh, Thank you. Just another question. We saw a table there which you created, and which basically resulted in better performance. Like when we are calling the data or reading the data in from different partitions of according to the year.
Yeah.
So it was utilizing the file paths of those specific partitions. Was that table automatically created, or we have to call a specific function? I missed that part.
So the create external table.
No, not the create external table. So basically, we had the data, we pulled it in, right? And then we were trying to read the data according to only specific years, right? Then you partition the data according to the best practices, that this is the way that we should do it: year, month, date. We
Yeah.
did it in year, right? And then you were reading the data from 4 of the random years. So in order to do that, the optimized way was to utilize the file paths.
Yeah.
So in order to get that table where file paths were stored according to the partitions it was referring to, was that table automatically
So I
created?
showed two scenarios.
Yeah,
One live against external data set,
right.
where we only create the external table, which with select open row set and file filter, file path. So that is just a live query. It doesn't bring the data in. When you create external table, we only keep metadata here, and we use the metadata to filter. The other demo I did was ingesting into a SQL table.
Right.
So that one was like a select into. Yeah, select into from an external or insert select from a data
External
source.
source, yeah.
So that one creates a table in SQL. So I showed both the import scenario and export scenario, and accessing data where it is.
Right. So, okay. My question was basically that partitioning information table, the metadata table, is that automatically created?
No, you have to create an external table.
We have to create an external table. Okay. And does this have the facility or your capability to write in delta format?
The delta format is not there yet,
Okay.
right? We can access it, but we can only export it as Parquet.
As Parquet.
Yeah.
Okay, got it. Thank you. Thanks
Yeah.
a lot.
Thank you. Something like that follow up. So this is still in our roadmap.
Yeah.
So
Okay.
we don't have a date or anything to share yet. So
Okay.
it'll
it's very
probably come
important.
in Azure first, since it's
Yeah, that would make more sense.
yeah.
And then would it honor if we have like a ADLS too, will it honor the ACL access as well?
Yeah, I mean, these are, I mean, obviously we can look into all the options, but I'd also recommend submitting a feedback to aka.ms/SQL feedback. So we get more input from customers. So that's helpful for us.
Okay.
Hi there. What's the extra resources required locally on the
But let me
in
come
terms of
closer.
as
I'm
a
hearing them more than you.
sorry?
Yeah.
What's the extra resources would require if I have a lot of external data source which I
I
try
mean,
to aggregate?
as you see,
from?
obviously, if the data is already stored externally, you're good. Your main resources will be compute and memory, because you're running
local-
queries, right?
on the
Analytical
local.
queries. And if you're ingesting data, obviously that uses both compute and memory. So you will have to be careful on separating your relational workloads, like your transactional workloads, from your analytical workloads. A lot of customers don't want to put both of them in the same database system at the same time. They use like a different server for that,
Yeah,
but like a replica or something. But
because
those are the two main you have to worry about.
yeah, because we potentially have quite a lot of endpoint try to extract from. So potentially it could have on the initial payload we could have quite a lot of
If you're just querying, it should not be. If you're importing data, yes.
okay.
Yeah.
Hello. When we try to import data from a CSV, if it is a big file, all it is loaded while it is processing in TempDB is used, or will it be used in the database where we're running this query?
It'll go to buffer pool first when
Okay.
you're inserting, and then checkpoint will flush it to disk.
Okay.
Yeah.
What if the data is corrupt? And obviously, as simple as loading CSV using
Yeah, if SQL Server is a relational database engine, so
Okay.
you need to have it's a very strongly typed schema, right?
Yes.
If you don't if the data violates the schema, it'll fail at the row where it violated. Right?
Okay.
Just like BCP or bulk
Yes,
insert,
okay.
same thing.
Oh, thank you.
Thank you, folks. We're out of time. More questions, please come to the Microsoft booth, and we have a lot of colleagues to help you.